All right. So section 3.1, we are going to continue talking a little bit about lines and linear functions that we've been building on in chapter 2. And what we're going to do is we're going to examine systems of linear equations in two variables. So we've already dealt with linear equations. We've graphed them. We've determined that linear equations are functions. And again, last time we graphed them. So now we're going to use them in a slightly different way. So starting out, an ordered pair that satisfies all the equations of a system at the same time is called a solution. Okay. So an ordered pair that satisfies all the equations of a system at the same time is called a solution. So in example 1, I show you what is a pretty typical system of equations. We've got 2. X plus y is 6 is the first equation. 4x minus y is 14 is the second equation. And our first exercise is nice and simple, is just to determine if the ordered pair is indeed a solution. And the reason I ask this question, and the reason I'll put one of these on the test, is just so that you remember that it has to satisfy both equations. If it satisfies one and not the other, it's not a solution to the system. So here we go. I'm going to plug and chug. So I'm going to take the x is 4 and the y is 2. I'm going to work this first example along with you. So x plus y is 6. So I'm going to put in 4 plus 2 is equal to 6. Is that a true statement for the first one? Yes, good. I think we would all agree that 4 plus 2 is equal to 6. The second equation is 4 times 4 minus 2. And I want to know, is that equal to 14? Well, we might need to do a little bit more just to be really super confident. So 4 times 4 is 16 minus 2. And is 16 minus 2 equal to 14? Yes. Yeah, don't lose your confidence now. Yes, it definitely is. So the ordered pair 4, 2, when I put the x is 4 and the y is 2 into both of these equations, I get a true statement both times. So yes, this is a solution to that system of equations. So I'll leave the work there. There's not a whole lot of work to it. I would like you to determine in exercise 1, is the ordered pair -1, 7 a solution to that system of equations? All right, so check your busy work with my busy work. If you came to a different conclusion, then let's talk about that. Okay, don't leave here confused about any of these things, please. So I'm going to take the x value -1 and the y value 7 and plug it into both of these equations. So the first one is going to be 3 times -1 plus 2 times 7. And I want to know, is that equal to 11? Well, let's determine. 3 times -1 is -3. 2 times 7 is 14. And -3 plus 14 is indeed equal to 11. So the first one works out great. But remember, we have to check both. So I'm going to take the x is -1 and the y is 7. I'm going to plug it into the second equation. And so I get -1 plus 5 times 7 is equal to 36. And that's -1 plus 35 equals 36. And -1 plus 35 is not 36. It is 34. So that is wrong. That is not a solution. And so -1, 7, while it worked for the first equation, it did not work for the second. So is -1, 7 a solution to the entire system? The answer is no. Okay, it's no, not a solution. Everyone understand the difference? You tracking with me? To be a solution, it has to work for both equations. Well, take another shot at it in case you didn't like that particular problem. Exercise 2 is just another variation of the same thing. Determine if negative 4, 2 is a solution to that system. All right, so in this one, I'm going to take the x value negative 4 and the y value 2 and plug it into both equations. So the first one is 2 times negative 4 plus the y value, which is 2. And I want to know, is that negative 6? So 2 times negative 4 is negative 8. And negative 8 plus 2 is negative 6. So we're 1 for 1. So far, so good. We'll give that a little check mark. The next one, I'll take the x is negative 4 and the y is 2 and plug it in to the second equation. So that is negative 4 plus 3 times 2. And I want to know, does that equal 2? So that's negative 4 plus 3 times 2 is 6. And then negative 4 plus 6, indeed, your calculator can tell you that is 2. So again, we got a true statement. So good both times. So what's my answer to the question? Is negative 4, 2 a solution to the system? Yes, it is. Okay, great job. So far, we so good. We doing all right. Okay, well then, now that we know what it takes for something to be a solution, now I want to know, what does it mean? Okay, what exactly are we doing here in these particular problems, which is a great question. So I've got an example, and you're going to do one just like it. We're going to take this system, and since we've spent time graphing these lines, we're going to graph, and we're going to see what happens and what does it actually mean, what's going on when something is a solution. So here's what I'm going to do. I'm going to graph this top equation. I like to graph using the slope and the y-intercept. So I'm going to continue. If you like to graph by plugging in points, then you are welcome to do that. Okay. However, you can accurately get that graph down onto your paper. So I've got the x plus y equals 5. To solve that for y, it's just one quick little step. So I'm going to subtract x from both sides, and I get y is equal to negative x plus 5. I know we've done a bunch of these. This is just a cute little review. What's the slope of that line right there? Negative 1, which I'm going to write as negative 1 over 1, so that I have a ratio. And then what's the y-intercept? Yeah, there you go, 0, 5. Perfection. Well done, everybody. So that's just what we did on the last unit. We also reviewed that as part of our discussion of functions, because lines are functions. And so 0, 5 is my y-intercept. So I'm going to make a cute little dot up there. And then I'm going to go down 1, right 1. So negative 1 in the y, 1 in the x. Negative 1 in the y, 1 in the x. I'm going to do this many times because I'm just having a lot of fun doing it. Negative 1, 1 more. Now I'm getting bored. So 1 more. There we go. So I'll connect these dots. This orange line's the first line. Put some arrows on it. It's a beautiful line. Maybe you're working ahead of me. Maybe you're right up with me. That's fine either way. I'm going to graph the second line in the same format. So I'm going to solve that second one for y. I'm going to first subtract 2x from both sides. And I get negative y is equal to negative 2x plus 4. Then I'm going to divide both sides by that negative 1. And don't forget to distribute. think you all did pretty good on that on the test. I was impressed, but don't let up. Don't forget to distribute that -1. A -2 divided by a -1 is a positive 2x. A 4 divided by a -1 is -4. So that gives me a slope this time of 2, which I'll write as 2 over 1, and then a y-intercept of -4. All right, so -4, I go down 4, 1, 2, 3, 4, and then 2 over 1 is 2 in the y, 1 in the x. So up 2, 2 in the y, 1 in the x, great. 2 in the y, 1 in the x, great. 2 in the y, 1 in the x, great. 2 in the y, 1 in the x. Okay, and now I'm going to connect those dots. And then you're going to answer a quick question for me, which is probably what most of you were anticipating anyway, is what we're seeing here. When I talk about the solution to a system of equations, what is physically happening at the solution? It's where the two lines are intersecting, right? That's why in those previous problems, the point that I gave you had to work in both equations, because it's where the two equations intersect. So I'm just going to draw a little arrow in case you didn't know that intersection right there, that's the solution. And in this case, we can read that right off the graph. I can just go ahead and say, okay, I'm going to go over 1, 2, 3 in the x direction, and then 1, 2 in the y direction. So the solution is the point 3, 2. We're going to continue to write our solutions as solution sets, just like we did when we solved equations. So before I move on to the next problem, I'm going to put some braces around this, because you can have not with linear equations, but when we do this in college algebra, you can have situations where you have more than one point as your solution. Okay, so that becomes a fun situation. All right, so I'm going to flip the page. I hear a lot of you already doing that, so I'm going to give you a couple minutes. Go ahead and do the same thing. Exercise 3 is for you to do. Graph both of those lines and determine what the solution to that system is. All right, so I'm going to get started. If you're still working, keep working. There's no reason not to. So the first equation is 2x plus y equals -5. I'm going to solve that for y just by subtracting that 2x from both sides. and I get y is equal to negative 2x minus 5. So that means that my slope is that negative 2, which I'll write as negative 2 over 1. The y-intercept is the negative 5, so that's 0, negative 5. So there's my slope. My y-intercept, that's the information that I need to graph. So go down 5. And then the slope being negative 2 over 1 means down 2, right 1, down 2, right 1. Well, I want a few more points since I know I'm going to be hunting for the intersection. So I'm also going to go up 2, left 1, up 2, left 1. We'll do that a few times. Up 2, left 1. That looks good. So there is my first line successfully drawn. If you have any questions, if you're not following along, those are great things to ask so that I'm not leaving you behind. And so then the next equation, I'm going to do the same thing. I'm going to solve it for y, and I get 3y is equal to x plus 6 in this case. Divide both sides by the 3. Again, don't forget to distribute. And so in front of the x, right now I have a 1 divided by 3, so that's 1/3 x. And then 6 divided by 3 is plus 2. So my slope is 1 over 3. The y-intercept is 0, 2. And there again is the information that I need to graph that line. So the y-intercept is 2, so there it is, up 2. 1/3 means up 1, right 3. So up 1, right 3, up 1, right 3. I could connect these dots, but let's just be certain. Down 1, left 3, down 1, left 3. Perfect. Connect the dots. Woohoo. And I see that those two do intersect. What is the point of intersection that we have here? Perfect. The point is negative 3, 1. Okay, back 3, 1, 2, 3, up 1. And that is how I find that. I'm going to put that in some braces because that is my solution set, that ordered pair. You might say, why do I have to do that, Kirkster? Well, the reason is if I just leave it negative 3, 1, then that begins to look like an interval. Right? It looks like interval notation, and it's just a single point. It's not an interval on the number line. So that's why notation gradually becomes more and more important, and why I put a little bit of a premium on it in this class and a lot of a premium on it when you get to college algebra. Okay, so far so good. We doing okay? Any questions, comments, concerns? Most of that is just reviewing graphing. Okay, so if you're still struggling with graphing lines, then let's talk, because I am going to put some graphing on the next test. There's going to be a problem just like this on the next test. And then as part of our function discussion, I had you graph a couple lines. I'm going to put one of those on the test. Okay, so I'm telling you up front. So if you're still struggling with graphing, that's something we should talk about. I don't want you to go into the test knowing that those are going to be problems you're going to struggle with. Okay, so get with me, email me, talk to me, whatever you need to do. Now, graphing is a fun and delightful way to solve a system, but it's not always practical, especially if you're going to get an intersection that might be a fraction. Okay, I'm not going to do that to you. I'm not going to make you read a fraction off of a graph. That would be rude. So we have a couple of other methods of solving. Now, to be completely honest with you, using substitution for linear equations is, I mean, sometimes it's fine when they're set up nice and easy, but I don't always use this. But the reason I like to talk about substitution is when you get to college algebra, we will solve nonlinear systems, and most of those you have to do by substituting. Okay, so it becomes a useful tool. So it's always good to remember this. So what we're going to do is we are going to come up with the answer to this system right here, which is 2x minus y equals 6. And then the other one, I've already kind of made this system so it's nice and user-friendly for us. X equals y plus 2. So the premise to substitution is this. If there is a variable that you can easily solve for or is already solved for, that's a pretty good time to use substitution. And so what I'm going to do now is, since this second equation says wherever I see an x, that is equal to y plus 2. What I'm going to do is I'm going to take this y plus 2, and where am I going to substitute it, do you think? the other x, right? So I'm going to substitute it right up here in the other x. That's the premise of the substitution method. So I'm going to do my work over on the right. So instead of 2 times x, I have 2 times y plus 2. Notice the parentheses. Okay, I'll have to distribute because that whole y plus 2 exists where the x was. Then I have minus y equals 6. All right, before I speed up, have I lost anybody at that step right there? We okay with the substitution step? At this point, once you've made the substitution, I'm going to solve this equation. This is what we've been doing since the first day we met each other. Okay, so I'm going to distribute. 2 times y is 2y. 2 times 2 is plus 4. Minus y equals 6. 2y minus y is 1y plus 4 equals 6. I'm going to subtract that 4 from both sides, and I get that the y value is equal to 2. Now, we're not quite done. What do I have to do from here, do you suppose?
Plug in y.
Yeah, I got to plug in y. I got to resubstitute and figure out what x is. Now, you can use either equation, but in this particular problem, one equation is already set up. So I'm going to plug in my y value into this bottom equation. So this bottom equation says x is y plus 2. So in this case, it's going to be 2 plus 2. So x is 4. Now, once you've done this, don't miss out on getting all of your points. All the points on the test. Your solution is an ordered pair. It's a point. So write it as such. So it's the x value 4, the y value is 2. I don't want people to think that that's interval notation, so I'm going to put some braces around it so that everybody knows it's a solution set. That's the substitution method. So I've given you one right below it that's already set up to solve nice, quickly, and cleanly. So go ahead and try exercise 4. And then we'll talk about what happens if one of the equations is not already solved for a variable. All right, so let's see how you did. Again, if at any point you did something different or you got a different outcome and you're not seeing why, please don't hesitate to ask a question. If you have a question, it is 99.9% sure that somebody else has the same question. So this second equation says x is equal to 2 minus y. So wherever I see an x, I can substitute the 2 minus y. So I'm going to plug it in right here. So I've got 5 times the x value. So I'm going to put some parentheses. And I'm told that that x value is going to be 2 minus y. And then minus 3y is equal to negative 6. All right, so that's the difficult first new step. The rest of this is just using skills that we should already have in our algebra tool bag. And so now I'm going to go ahead and I'm going to solve this. So I've got 10 minus 5y. That's distributing that 5. Minus 3y is equal to negative 6. And then I have 10, negative 5 minus 3 is negative 8y. I'm going to subtract that 10 from both sides. And I have negative 8y is equal to negative 16. And last but not least, I divide by the negative 8. And I get, once again, y equal to 2. That's coincidence from the previous problem. Don't know why that worked out the same. And now I'm going to take the y value of 2. I'm going to go back up to the other equation to figure out the x value. The x value is 2 minus whatever the y value is, which is 2. And so the x value is 0. All right, so that's our solution. The x value is 0. The y value is 2. I'm going to put some braces around it. And there's my solution set. Before we flip to the next page and we do another problem that's a little bit more stimulating. Anybody got a question about this one? All right, flip to it. Exercise 5. Exercise 5, I'm asking you to use substitution again. Before you do, though, this is a situation where substitution would make sense, because notice the next problem that we're going to do a different method. I would not use substitution on the next one, because there's not an easy variable to solve for. Whatever you do, you're going to end up with fractions. And I know you hate fractions. I hate fractions. We all hate them. Okay, we don't want to mess with them. Okay, so that's why we're going to have a different method when we get to the next problem. So on this problem, there is only one variable that it makes sense to solve for. Can anyone propose to me what variable that is? The y. Which y? In the top equation or the bottom equation? The y in the top equation. So what I want everybody to see is that's the only one that makes sense, is because there's nothing in front of it. I'm not going to have any fractions at all to deal with, and I want to avoid those when I'm substituting. Okay, so here's what I would like you to do then. I want you to solve that top equation for y, and then use what you get to substitute into the second equation to figure out your solution. I'll give you a couple minutes. If that was not clear, if I did more damage than good, raise your hand. I will come to you and help clear up any problems. Okay, so what I asked you to do, start this off, was We picked the easiest variable to solve for, which is going to be this y right here because it has no coefficient in front of it. So I will have no fractions. And so I have one step to solve this for y, and that is to subtract 4x from both sides. So what I end up with is y is equal to negative 4x plus 5, or you have that 5 minus 4x. Either way, the order does not matter. So now I'm going to take that y value, y is equal to this, and I'm going to plug it in for y right here in the second equation. So what I have is 2x minus 3 times y. Well, y is negative 4x plus 5, or 5 minus 4x if you prefer, and that's equal to 13. So let me stop. That's the difficult part. I'm going to have you do one just like this, maybe two just like this on the test. I'm going to ask you to substitute. So is there a question about how we got to this point right here? Anybody at all? Okay, so here we go. Now I'm going to do the part that should be more familiar, which is the solving part. So negative 3 times negative 4 is plus 12x. Negative 3 times 5 is negative 15. 2x plus 12x is 14 of them. I'm going to add 15 to both sides, and if you'll allow me, I'm going to continue up on the left where I have a little more space. So when I add the 15 to both sides of this, I have 14x on the left, and then 13 plus 15 is 28. And then I divide, and that gives me my first part of the problem, and my x value turns out to be 2. Now that I got that, I'm just going to come back over here underneath this equation that I took the effort to solve for y, and I'm going to take advantage of that effort now, and I'm going to say, okay, then y is negative 4 times 2 plus 5. And so y is equal to negative 8 plus 5, which is equal to negative 3. And like every other problem, just don't forget to write it as a point. That's your solution set. So the x value turns out to be 2. The y value turns out to be negative 3. And so that I don't mistake that for an interval, I put that in braces, and that's my solution set. So that's substitution. And so if you're, I will ask you to use the substitution method, so practice that a little bit, but I only recommend using the substitution method when there is a variable that is nice and easy to solve for. Otherwise, the substitution method becomes a burden, and I don't want you to be burdened. These problems hopefully should go by nice and fast. So what happens then when I don't have a variable that's nice to solve for? So for instance, this problem, I've got 2x plus 3y is negative 6. And 4x minus 3y equals 6. So notice, and for any variable, I'm going to have to divide by something. So I'm going to have fractions, and I want to avoid that. So what we're going to do is we're going to use what's called the elimination method. And I have set this problem up to be done nice and quickly just to show you what the elimination means. And then we'll build up from here. So notice, if I was just to smush these two equations together, if I'm just to add them together, what's going to happen to the positive 3y and the negative 3y if I just add these two equations together? They're going to cancel. They're going to get eliminated. And that's the whole premise to the elimination method. You want to get rid of one of the variables. So here I could just add these up because of the way the problem was given to me. So the x's, 2x plus 4x, that's 6x. The 3y and the negative 3y, those cancel. And then on the other side, the negative 6 plus 6, that's 0. That's a number. That's okay. Don't be scared of it. And then I divide. And then I have x is equal to 0. Okay, when I have 0 of something and I divide it by 6, I still have a 0. Okay, so there's half the answer. We're done. We're half done with the problem. Let me trace over that. My pen decided to be, there we go, obstinate. So x is 0, and now I have to figure out the y value is. Any proposals on how I figure out the y value is? Yeah, it doesn't matter where. Pick your favorite equation. I don't have a favorite equation here, so I'm just going to use the bottom one. I'm going to take the bottom equation and I'm going to plug 0 in. And if you don't believe me that we'll get the same point, you pick the top one and plug the 0 in for x, and we'll compare notes. Okay, so it should work out the same either way. So I'm going to plug x as 0. So I've got 4 times 0 minus 3y is equal to 6. 4 times 0 is 0. Love plugging in 0. And then when I divide by -3, I get that the y value is -2. And so my ordered pair, my x value is 0, my y value is -2. So that does not get mistaken for an interval. I put some braces around it, and there's my solution set, 0, -2. The example right below it, exercise 6, I've also given to you in a format very straightforward to practice eliminating. So go ahead and solve that, please. All right, so once again, I gave this one hopefully as a straightforward example. You notice my -2y, my +2y, those are going to cancel straight away when I add these equations together. So I'm going to do that. So 8x plus 5x, that turns out to be 13x. The y's cancel. That's great. They're eliminated. That's the whole premise of this method. And 5 plus -18 is -13. And when I divide by 13 on both sides, I get x is equal to -1. Boom, we're half done with the problem. Did I do something wrong? Okay. All right, so then I'm going to take the x is -1. Again, it does not matter which equation. If you pick a different one than I do, it will absolutely work out the same. I'm going to use the top one this time just to be different. And so when I put -1 in for x, I've got 8 times -1 minus 2y is equal to 5. Then I have -8 minus 2y is 5. Add the 8. And I get -2y is equal to 13. And then divide by -2. And I get y is -13 over 2, or if you like decimals, -6.5. That's fine as well. And so that means my answer is x is -1. The y is -13 over 2. Fractions are friends. We don't always like them, but they're useful. And there we go. There's our answer. That's our ordered pair. Before I move on to the next problem, I don't want to rush. Anybody got a question? All right, the next problem, exercise 7. The reason I put this one on here is, what do I do when I got an equation with fractions? Now I got a headache and everything. What's going on? So what I would recommend you do, here's step 1. I want you to clear the fractions of this second equation and then solve by elimination. Should work out to be pretty nice, nicer than it looks now. just so we're all moving in the same direction. If I'm going to clear the fractions on that second equation, what are you multiplying every term by?
4.
By 4, yes, that's the common denominator. You could use 8, that'd be fine, but 4 is going to be the make this problem the easiest. All right, so when I multiply every term by 4, here I've got 4 times a half. 2 goes into 4 and leaves 2, so I start off with a 2x right there. The next one, when I multiply 4 times a fourth, 4 goes into 4 and leaves 1, so I have plus 1y, or just y. And then on the other side of the equal sign, 2 goes into 4 and leaves 2, so I have 2. So that's what I get when I clear the fractions. I'm just going to bring that top equation down. I've not done anything to it. And I have negative 2x plus 5y is equal to 22. And again, this is another example where the problem is set and ready for you to eliminate without doing anything else. So negative 2x plus 2x, those cancel. 5y plus y is 6y. 22 and 2 is 24. And when I divide both sides by 6, I get y is equal to 4. Great. You can pick any equation you want to plug that y in. I'm just going to use the top equation because I can read it most easily. So I'm going to put the y value of 4 into this equation right here. So I have negative 2x plus 5 times 4 is equal to 22. 5 times 4 is 20. I'll subtract that 20. 22 minus 20 is 2. And then I divide by the negative 2. And I get x is equal to negative 1. So there's my x, there's my y. So my ordered pair answer, the x value is negative 1, the y value is 4. Again, I don't want that mistaken for an interval, so I put some squigglies around it so everybody knows that's a solution set. Okay, we're heading to the finish line here. A couple more elimination problems, though. What happens if the problem is not set up straight away to be able to eliminate? So this next one, my example, I'm going to work this one along with you. Notice if I was to just add these equations, 5x and 2x is 7x, that's not helpful. And then negative 2y plus 3y is 1y, still not helpful. Nothing eliminates. So I have to make something eliminate. So you get to help me here. Do you want to eliminate the x's or the y's? Okay, y's. That's fine. There's no benefit to either one. So we could have done the problem either way. I was not expecting a particular answer. So if I'm going to eliminate the y's, notice right now I've got a 2 and I've got a 3. What's the common multiple between 2 and 3? 6. So here's what you want. I want to have a -6 in front of one of the y's, and I want to have a +6 in front of the other. I'm just going to call a quick timeout. We'll come back. That's how we're going to do it. But let's say somebody had said you want to eliminate the x's. Okay. 5 and 2. What's the common multiple between 5 and 2? 10. So you'd want to have a -10 in front of one of the x's and a +10 in front of the other. You can do it either way. But we're going to do the y's. So I'm just going to put some parentheses here. What do you suggest I multiply the top equation by?
3.
Okay, 3. What is that going to give me in front of the y? 3 times the -2 is going to give me what? A -6. Okay, keep that in mind. I've got a -6 in front of that y. What should I multiply the bottom equation by then? 2. What is that going to give me in front of that one? +6. Okay, so notice there was already a negative in there, so I didn't have to worry about making one of them negative. Okay, on the next one, I'll have you eliminate the x's, and just to make sure that we know what to do in the different situation. Okay, so here we go. Now that we've determined that, let's go ahead and do that multiplication. So 3 times 5 is 15x. 3 times -2y is -6y. And then 3 times 4 is 12. For the bottom equation, 2 times 2x is 4x. 2 times 3y is +6y. And then 2 times 13 is 26. Boom. Before I move on, that's the difficult first step. The rest of this should not be a big deal if you didn't ask a question about the other ones. Anybody got a question up to this point about how we got here? All right, well, you can always change your mind and ask the question at a later time. 15x and 4x is 19 of them. The 6y's cancel. That's what I wanted. They're eliminated now. 12 and 26 is 38. And when I divide by 19, I get x is equal to 2. At this point, pick your favorite equation that you see on the page. I'm going to pick the x equals 2, and I'm going to plug it into this bottom equation just so I can use the white space right below it. That's my only thought there. I have no secret magic that I'm withholding from you. I would tell you if I had some sort of secret. So I'm going to take the x as 2, and I'm going to plug it in here. So 2 times 2 plus 3y equals 13. 2 times 2 is 4. Subtract the 4, and I get 3y is equal to 13 minus 4, or 9. I've run out of room, clearly, so I'm just going to go over here to the left to finish this up and divide by 3. And we get the y value is 3. So there's my x and my y. Let's mush those together. The x value is 2, the y value is 3. And I'm going to put them in some squigglies. There's my solution set. If you got a question about that, please ask it. That's probably the hardest problem we're doing today. Yes?
So why is it, I don't know how to do it. It's problems before, why is it already set up?
Because the other problems, I was just getting you ready. I gave some easier style problems so that you would see what the whole purpose of eliminating was, which was to cancel something out. So this is like a truer problem that you'll see where it's not already set up to be eliminated. You have to do that part to it. And that's why we're going to have 2 follow-up problems to this so that you can get used to doing that. Great question. So here's what I want you to do for exercise 8. Exercise 8, let's eliminate the y's. Okay, just like we did in the previous problem. And then in the next one, we'll eliminate the x's just to do something different. So exercise 8, eliminate the y's, figure out what you're going to multiply by, and do it, please. If you need me, raise your hand. I'll run over to you. So the two numbers are 7 and 3. So what's the common multiple? So we're going to multiply the 3 by what? No, you don't mess up. 3 times what's 20. And then we multiply 7 by what? There you go. All right. There you go. Got it. Very good. Very good. You figured it out. Love it. I'll let you teach the class. All right, so let's try this out. I asked you to eliminate the y's just so we're all doing the same thing. If you had encountered this problem on your homework, you could have eliminated the x's. There's no reason you could not have, okay? But I just wanted us all to do the same thing. So my coefficients presently are 3 and -7. The common multiple between those is 21. It's basically just 3 times 7. And so I'm going to multiply this top equation by 7 because 7 times 3 is positive 21. And then I'm going to do the bottom one by 3 because 3 times -7 is -21. And I'll be able to eliminate. So 7 times 2 is 14x. 7 times 3 is 21y. And then 7 times 19 is something. What's that? 133. That good? All right, great. Thanks for not making me do the arithmetic. I love it. 3 times 3 is 9x. 3 times -7 is -21y. And then 3 times -6 is -18. And so now when I add, now I have the same number, just different signs here. So when I add them, they will eliminate. Okay, so the 21 and the -21 are now eliminated. So 14 and 9 is 23x. 13 and -18 turns out to be, what is that? 115. Thank you again. And when I divide, perfect. Appreciate that. X is equal to 5. Love it. Pick your favorite equation of the original two. It absolutely does not matter. I'm just, again, going to use the bottom one because the space is right below it. So when I put x is 5, I have 3 times 5 minus 7y is -6. 3 times 5 is 15. Just a lot of arithmetic that we're doing. Don't forget, your calculator can help you with that. If you need it, don't be shy about it. So I have -7y is equal to -21. And when I divide by -7, the y value is 3. So my ordered pair is the x value is 5, the y value is 3, and then we'll put some braces around it, and there we go. All right, we're doing great on time. Exercise 9 is another elimination problem. Again, just so we're all doing the same thing, eliminate the x's this time. So if you want to be doing the same thing I do when I work the problem, eliminate those x's, and we'll compare notes in just a moment. All right, so on this problem, I asked you to eliminate the x's. So what's the common multiple between 3 and 5? 15. So what do you want to multiply the equations by? Okay, 5 and 3, I'm going to make one little alteration to that, though. One of those has to be negative. It doesn't matter which one. One of them, though, does, so they'll have different signs. So I'm going to do 5 and -3. Doesn't matter. If you did -5 and +3, that's fine. Don't change a thing. We will end up in the same place. Okay, you just need one to be negative so that when you add the equations together, they will eliminate. Okay, the reason we did not have to do that on the previous two problems is because we chose to eliminate the y's and they already had different signs. Okay, so that's why we did not multiply by a negative on those ones, in case you were wondering. It would be a great question. So now when I multiply the top equation by 5, 5 times 3 is 15x, 5 times 4 is 20y, and then 5 times -6 is -30. The bottom equation, -3 times 5 is -15x. Oh, that's good. I can already see that's going to eliminate. -3 times 3 is -9y, and -3 times 1 is -3. Now, when I add them together, the 15x's cancel because there's one positive and one negative. 20 minus 9 is 11y. -30 and -3 is -33, which ends up giving me a y value of -3. Again, pick your favorite equation. I'm just going to use the bottom one again. Again, there's no secret that I'm not telling you. I'm just using the space. If you use the top equation, you will end up with the same exact x value I do, guaranteed, because this point is supposed to be on both lines. So I have 5x, 3 times -3 equals 1. And then when I add that -9 to both sides, so I add 9. Uh-oh, my green pen is not happy with me for some reason. Okay, back to you, no problem. All right, so I'm adding 9 to both sides, and I get 5x is equal to 10. And then I will divide both sides of that by 5, and you can see pretty clearly that we're going to get an x value of 2. So my ordered pair is the x value 2, the y value -3. Put some squigglies around it because it's a solution set. Got two final problems for us. We've done all of the solving. These last problems are just a couple of special situations that might arise that we need to talk about. So real quick for me, in exercise 10, just eliminate the x's. I'm going to give you about 30 seconds to make as much progress on eliminating the x's as you can, and then we'll talk about what happened. All right, so on this one, I just asked you to eliminate the x's. It could have been the y's. It would be the same process, the same conclusion. So between 2 and 6, what's the common multiple? Okay, I'm going to multiply by -3 because the common multiple is 6. Okay, so I'm going to multiply this top one by -3. Yes, that is right. The reason it's negative is because I need one of the 6's to be a negative and the one to be positive. So when I multiply by -3, I've got -3 times 2 is -6x. -3 times -1 is +3y. And then -3 times 3 is -9. The second equation stays the way it is. And then notice what happens when I add these two equations together. What happens to the x's? They cross out. What happens to the y's? Oh, it's a festival of canceling. Yes. And so I have 0 on the left. And then what happens on the right of this one? -9 and 9, they cross out. They're 0 too. So I end up with this statement here, 0 equals 0. Okay, well, what does that mean? Well, first off, is 0 equal to 0, is that a true statement or a false statement? It's a true statement. Okay, so it's a true statement. What we have here is called a dependent system. What it means when you have a dependent system is you had two of the same line. Okay? As you said earlier, very well deduced. And so because you have two of the same line, when you draw them, you draw one line on top of the other. They intersect everywhere. Okay, so I'm going to summarize this because I want you to understand why the solution is going to be what it is. So a dependent system, I'm just going to write over here where I have some space. What you have is you have two of the same line. So when you graph two of the same line, they intersect at every point on the line. And so here's how you write the solution to that. I had to run to my office because this book does it different than the college algebra book. There's other ways you can write it. Here's how our book writes the solution set to where you have where every point is an intersection. So here's what we're going to do. We're going to write a squiggly for my set. And I'm going to write that it's the set of ordered pairs of the format x, comma, y. Defined by, that's what, if you're reading mathematically, that's what this bar right here means. It means defined by, so you can make a little note. So what I've written is the set of ordered pairs, x's and y's, defined by, and then I'm just going to pick the top equation, 2x minus y equals 3. That's the relationship that defines the x's and y's. So basically, again, to summarize, that's saying every point on the line is a solution to the system because it's two of the same line. All right, so with our final couple minutes, just going to do the same thing for exercise 11. Let's eliminate the x's again. So when I go to eliminate the x's, what do I need to multiply this top equation by to eliminate the x's? Okay, 2 on this one, yes. So what that gives me in the top equation is 2 times x is 2x, 2 times 3 is 6y, and then 2 times 4 is 8. The bottom equation is negative 2x minus 6y is equal to 3. I'm going to give you a second to get caught up so that you can see the difference in conclusion on this problem versus the previous one, and then you'll be free of me for another day. So notice on this one, when I add the equations together, the x's cancel, that's great. The y's cancel, so I have 0 on the left. But this time on the right, 8 plus 3, those don't cancel. 8 plus 3 is 11. Do I have a true statement here? Is 0 equal to 11? No, this is a false statement. And what you have here is called an inconsistent system. And what's physically happening in an inconsistent system is you have parallel lines. Do parallel lines ever intersect? No, that's why you get that false statement, because parallel lines never intersect. So there is no solution to an inconsistent system. And as we've done previously, when there's no solution to something, we write an empty solution set. So I'm going to write my braces with nothing in between. There's my solution set.